Your computer has one of the most advanced processors ever built, a CPU. It runs your operating system, your browser, it makes decisions, it handles everything. So you would expect that it should be perfect for artificial intelligence, but it isn't. In fact, it's terrible at it. So much so that the biggest tech companies in the world are spending billions just to avoid using CPUs for AI. Instead, they use GPUs, hardware originally designed for gaming. So now we have a contradiction. The smartest processor we have is bad at intelligence, but the graphics chip wins. Why? To answer that, we need to challenge something very basic about how we think intelligence works inside a machine. If a task is complex, you use a powerful processor. That's a rule we all intuitively follow. And CPUs are exactly that, powerful. Inside the CPU are a small number of highly sophisticated cores. Each core is engineered to handle complexity. They predict what your code will do next, they reorder instructions on the fly, they handle branches, conditions, unpredictable behaviors, and you can name it. In other words, CPUs are built for thinking. So naturally, you would expect AI to run best on a CPU. That would make sense, but that intuition breaks completely, because AI doesn't behave the way that you think it does. AI is not sitting there carefully making decisions like a human. It's not constantly branching through logic. It's not asking if it's then that. Instead, it does something almost boring, over and over again. Simple math, specifically matrix multiplication, and that changes everything. Picture this: two massive grids of numbers, thousands of rows, thousands of columns. Now imagine multiplying them together. It sounds like one operation, but it is not. It's millions of tiny operations. Multiply, add, again and again. Now scale that up. Modern AI models do not do this millions of times. They do it billions, sometimes even trillions of times. But each operation is simple. There is no deep thinking per step, no complex decision making, just repetition at an absurd scale. And that's where the problem begins, because CPUs were never designed for this kind of work. A CPU expects program to behave unpredictably. It's optimized for load some data, make a decision, branch into a different path, handle exceptions, and so on and so forth. It thrives on complexity, but AI doesn't need that. AI wants the opposite. It wants to do the same operation on massive amount of data, all at once. But the CPU only has a few cores, maybe 8, 16 or 32, depends on your CPU and when you watch this video. Each one is powerful, but there just aren't enough of them, because AI doesn't need smarter cores. It needs more work done at the same time. Now think about GPU, completely different philosophy. Instead of a few powerful cores, you get thousands of smaller ones, not 16, not 32, thousands. Each one is simpler, less flexible, and less intelligent. But that's the point. They are not designed to think. They're designed to repeat over and over again at massive scale. So instead of solving one complex problem quickly, a GPU solves millions of simple problems simultaneously. And suddenly, AI workloads start to make sense at GPUs. And now you can think of this workload to make sense at GPUs. Think of it like this. A CPU is like a team of senior engineers, highly trained and extremely capable. You gave them a complex problem, they'll solve it quickly and beautifully, like a piece of cake. But there are only a few of them. Now imagine a GPU. It's a factory, thousands of workers, each doing a small, simple task. Individually, it's not impressive work, but together they can produce at a scale no small team ever could. And AI is factory work, not engineering work. That's a shift most people miss. But even this explanation is incomplete, because having thousands of cores is not the real reason GPUs win. There is a deeper constraint, and it quietly dominates everything: memory. Let's go back to those matrices. They are not small. They are massive gigabytes, sometimes even larger. Before any computation happens, you need to move that data from memory into the processor. And here is the problem. Moving data is slow, often slower than the computation itself. Now we have a new conflict. Even if you had infinite compute power, you would still be limited by how fast you can feed that data. CPUs were not built for this. They're optimized for low latency, fast response times, and small chunks of data. They assume you're working with limited information, but making complex decisions. That's their strength. You cannot blame them. But AI flips the requirement. AI needs a huge amount of data streamed continuously at extreme speed, and CPUs simply cannot keep up. GPUs, on the other hand, are built for this exact scenario. They have extremely high memory bandwidth, hundreds of gigabytes per second, sometimes even over a terabyte per second. That means they don't just compute faster. They stay fed constantly. No waiting, no starvation. And that changes everything. Because in AI, the real bottleneck is not thinking. It's feeding the machine. So now the picture looks completely different. AI is not about intelligence in the way that we imagine. It's not about deep reasoning per step. It's about simple operations repeated at massive scale on massive data. And suddenly, the best processor is no longer the smartest one. It's the one that can do the most work at the same time without slowing down. That is exactly why CPUs are bad at AI. Not because they are weak, but because they're solving the wrong problem. They are built for flexibility, but AI needs a scale. They're built for decision making, but AI needs repetition. And that mismatch is everything. What started as hardware for gaming ended up powering the entire AI revolution. Not because GPUs are more intelligent, but because they're better at doing something very simple. And they can do that simple work millions of times at once. And in the world of AI, that's what intelligence really looks like. This is ML Guy, and together we are looking deep into the systems to understand how they work. Until the next video, good morning, good afternoon, and good evening. Bye.